Hello guys and welcome back. So let's take a look at this geo and convert it into a volume. So if we middle click here, we see it's a primitive. It has 500 points and it's made of polygons. If I hit the tab key, you can see there is this VDB tab with all the nodes related to VDB. Okay, there is also a volume section that is related to anything volume related in Houdini. These nodes primarily works with the Houdini native volume. Okay, they don't necessarily work with the VDB volume, but they're going through and adding supporting both of them. And for now, we're going to focus on the VDB volumes. So to convert the geometry into a density field, we're going to use a VDB from polygon, this guy. And I'm going to connect this. Instead of this distance VDB, which we're going to talk about later, I'm going to uncheck this and tick on density. And if we click, we see that this guy is now a volume. If we middle click, see we have a density field, and it's of a float type. And here it says VDBs, we have one VDB. Now let's say we want to use this object to emit smoke from. We can definitely do that, but I want to create some noise or a velocity vector to it. So what I'm going to do is I'm going to create a random attribute and just initialize some velocity, a v vector basically. And let's see, we have something. It doesn't matter what the value is. Inside the VDB from polygons, it can, while it's converting the geometry into a volume, it can also sample, and this is a keyword related to volumes, it can sample the data from the surface and create another field for us. So I'm going to click here, it says surface attribute, and I'm going to tell it to create a new field for me based on the point.v, which is the velocity attribute that we create. I'm going to call it val because that's the name we use to do that, so to refer to the velocity. So if I middle click, you see it's a vector 3 type. Apart from density, we can also create other fields. So let's create another random attribute, and this time I'm going to create a float. So I'm going to call this my attribute, and it's a float type, so dimension set to 1, and it's a random, so it goes between 0.1 and 1 in this case. And you can see it here, my attribute is a float. I'm going to copy that. Let's go here, and if I add another field, paste this guy, select the point attribute, I'm going to name the field as point attribute, and you can see it's visible here. And if I middle click, we have a float, 2 floats, and a vector field. Now, most of the time you don't want to see these attributes, the fields, apart from the density. Okay, and an easy way to hide these extra fields is to use a visibility node, and you can say hide everything except the density field. Okay, and now we're just looking at the density, and all the other guys are hidden. You can see here primitives not displayed in 3D 2, VDB count 3, and these are the 3 things that we have. Okay, now if we middle click again, you see this, it says voxel size here, set to 0.1. And the voxel is the unit or the measurement unit that builds the volumes. When we have a geometry, for example, it's made of points. With volume, it is made of voxels. Now voxels, unlike points, needs to be defined in a domain. If you click here, you see there is this bounding box shape, and that tells the volume that it can only have data in this domain. Okay, so if you have, for example, a small object here, the domain will shrink down, and you will have this domain filled with voxels. Now the voxels that are visible are the ones with the data. We don't see anything else that doesn't have data. Now let me show you what this voxel looks like. I'm going to create a box and set its unit to 10, 15, 10, and let's move it up. Okay, so let's say this is the volume, the geometry I want to convert into a volume. I'm going to create a VDB from polygon, and same look we did with this, we're going to convert it into a volume. You can see it here. Everything is good. Now I'm going to use a node called VDB visualize tree, and if I connect this, you see it shows me the squares. Now let me fill interior. Yeah, so it shows me a square representing subdividing this box here, or the domain, and these are voxels that are building the domain. So this volume is built off many boxes that are called voxels, and we have the size of these voxels is 0.1 at the moment. So we have 0.1, 1 voxel, 2 voxel, 3 voxel, all the way until it fills the domain. And same thing goes up. The smaller the voxel, let me lower this to 0.1. The smaller the voxel, the more precise the data is going to be, and the higher the resolution of the volume is going to be. It's like when you have a mesh, the more points you have in the mesh, the higher the resolution. With volumes, we have a voxel size. The smaller the voxel size, the more quality we can store inside this domain or this volume, and the heavier it's going to be. Let me change this back to 5. Okay, so you see now it's much denser, and we have more. If I middle click, we have 12 million voxels now, and this is the resolution. We have 200 along the x-axis, which is this. So 200 voxels along the x-axis, 200 along the z-axis, and 300 along the y-axis. So that's how much data we have. Now let's go back here, and let's look at and let me copy this. I want to turn these off so it's faster to work with, and I have a light already, so I'll talk about that in a second. So I'm going to show you the details. Right now it's set to 0.1. We have 225,000 voxels. I'm going to lower this to 0.01. It's going to obviously take longer. You can see the processing here, and it's going to convert this into a much more detailed volume. See, now we captured a lot more resolution, but we also have 225 million voxels, and you can see the resolution here. This is very high res. Okay, we don't want to get this high. When it comes to sims, between one of the axes shouldn't go higher than 600 at this point. Okay, try to keep these 3 values below 600, and between 200 and 600, that's the mid to high res range. Higher than that is gonna take a lot longer to process and work with, so keep that in mind. And the more resolution we push through this, see here it's using 200 megabytes, the more the higher the resolution, the more memory it's gonna take. Cool. So let's take a look at lighting this quickly. Let me actually lower this resolution a bit so it's faster to work with. Let's go up. Let me hide these guys. And for the lights, let me turn this off. And this is the raw volume. There is no lights in the scene. I'm just gonna hit tab and type in light. Now we have a point light. Let's move it to the side. And the intensity is very low, so we can increase that. And now we have volume lighting. Okay, let's copy this and move it to the side. And Houdini has probably one of the best OpenGL display when it comes to volume. Okay, so that's our volume. Cool. So in the next video, we're going to learn about processing the data in VOPs and how to work with it. Thank you guys for watching, and see you in the next video. Bye bye.